Okay, today we're going to talk about factoring quadratics. The notes say that you need to find two numbers that multiply to give you the last number and add to give you the middle number. So it's kind of like a little puzzle. So let's look at the first example. Example number 1 says x squared plus 10x plus 21. So my suggestion is that you start with the last number, multiplication first, because there's lots and lots of numbers that add to give you 10, start with 21. So if I start with 21, my options are 1 times 21 and 3 times 7. And that's the only numbers I know that multiply to give me 21. So then I look at these numbers and I say, okay, I need to make sure I can add to give me 10. So my option I would pick is 3 and 7. So you write factored in two sets of parentheses. And so you get x plus 3, x plus 7. And that's the answer. We're going to talk a little bit more about the answer and why it is that way. So first of all, you should take 2 seconds and check. 3 times 7 is 21. 3 plus 7 is 10. So that works. And then why this works is because really you're just undoing this. The distributive property says that if you take this, if you do x times x, you get x squared. X times 7 gives you 7x. 3 times x gives you 3x. And 3 times 7 gives you 21. And so then if you add like terms, you end up with x squared plus 10x plus 21, which is what you started with. So really this is just undoing this into two sets of parentheses. Now, the other thing is this is not the only correct answer. It does not matter what order you put these in. If you were to do x plus 7, x plus 3, that's a perfectly fine answer. It doesn't matter which number goes first in the parentheses. Okay, next example says x squared plus x minus 12. So I'm going to start with negative 12. And I'm going to worry about the negative in a minute. I'm going to make my list. 12 is 1 times 12. 12 is 2 times 6 and 3 times 4. So I'm looking at this and I want to figure out how to get this has a 1 there, right? So we have this 1 that we don't actually write, but there's a 1 there. So what are my options of getting 1? Well, 1 and 12, whether I add or subtract, is either going to give me a 13 or 11. So that's not going to work. 2 and 6 is either going to give me 8 and 4. This guy is closest to getting me a 1 because I can change the sign. If I want 1, isn't 4 minus 3 equal to 1? Right? It doesn't always have to add. So I'm going to pick 4 and negative 3. So I'm going to put x plus 4, x minus 3, and then I'm going to take the 2 seconds and check. 4 plus negative 3 is 1. 4 times negative 3 is then negative 12, and that's when the subtraction sign comes into play. So this is my answer. And again, you could write this differently. You could put the 3 in front, but you've got to make sure. The only thing that matters is that it doesn't matter what order these are in. It matters that the minus sign is with the 3 and the plus sign is with the 4. Okay, one more example is x squared minus 10x plus 24. And this gets a little bit tricky, just so you know. So 24, I look at 24, and my options are 1 and 24, 2 and 12, 3 and 8, and 4 and 6, right? So right off the bat, I'm going to think, oh, look, 2 and 12. 2 and 12 could give me 10, right? So if I had x plus 2 and x minus 12, because 2 minus 12 is negative 10. However, 2 times negative 12, so if I do 2 minus 12, I get negative 10. If I have 2 times negative 12, though, I get a negative 24. And this guy is not negative, he's positive. So that guy does not work, actually. So I'm not going to keep this guy. I'm going to, oh, I didn't mean to erase that, I'm sorry. I'm going to not use that one. So my next bet, when I look at this list, is what gives me 10. I'm going to pick 6 and 4. Well, if I have a 6 and a 4 and I want to get negative 10, then I would have to have x minus 4 and x minus 6. And again, I'm going to take 2 seconds and check. Negative 4 plus negative 6 gives me negative 10. And negative 4 times negative 6 gives me positive 24, which is what I want. And so this is my answer. Don't, even though there's some, you need to double check, because otherwise, like, one part will work, the other part might not work.